today's tutorial, and today in lab 7 we are going to see how we can do AC analysis with the help of LTSpice, right? So previously we did DC analysis, and today we're just going to do AC analysis. So like I discussed before, just like the tutorial of the DC analysis with the help of LTSpice, you saw these points actually discuss how you can interpret a certain command. But what we are going to do is straightly jump to the circuit construction, and then we are going to see how we can do AC analysis over here. So you can see this is a very simple circuit, and over here you have a voltage controlled current source whose positive terminal, it's going to be connected over here, and the negative terminal is connected over here, right? And the current source, it's dependent on a voltage which is across this terminal, so you just have to connect that accordingly. And what you can see over here, it seems like a DC voltage source, but it's not. It's an AC source, and this is a 20-volt amplitude, and the phase over here is 0, right? So how we are going to do that? So let me move on to the circuit over here. So you guys are looking at the circuit. All I did was just to I just built that circuit that was shown in the manual, okay? But there are a couple of new things that you have to see over here, which is like, how do you define an AC source? AC source is nothing but if you just plot a DC source. Let's say it is, when you go to the command window, then you're gonna find this one, and then let's say it's a voltage source, right? So what you have to do, just press a voltage source, press it just like this. And then when you right click it, then you're going to find an advanced option. So go to advanced option, and then you're going to see you can select different kind of waves from here. So I'm just going to take an easier way. This is a very simple way to show, because our circuit shows us accordingly. You can see over here it's a 20-volt amplitude, and it's the phase, right? So these options that you have over here, it gives you to select an amplitude and also the phase. So what you had to do was select just the amplitude and then the phase, and then if you just click OK, then this becomes an AC source. Simple as that. So that's what I did just right over here, okay? And after this, what I'm gonna do is I'm gonna simulate the circuit. You can see it tells us to do the analysis starting at 1 Hertz and ending at 100 kilohertz, right? So how do I do that? So over here, I just have to click run. And when I do so, previously what you did was you just did a transient analysis, right? Today we are going to do AC analysis. So let's do 5 points per decade. The start frequency will be 1 Hertz, and this is going to be 100 kilohertz, like it said. And if I do that, if I click OK, and that's how circuit gets plotted. After I plot, I gotta see like what exactly do I have to plot, right? So over here it says the voltage gain, which is V0. V0 is this one across this 1 kilo ohm resistor, and this V is 20, that's gonna be across this one. So they want to see the voltage gain at 100 Hertz and the same voltage gain at 100 kilohertz, right? So that's what we're gonna see. So I'm gonna switch over to LTSpice. So over here I just did nothing. If I just show it to you again, what's happening is I first want to know what's this node. So when I clicked it, it's 005. When I click this one, this is 002. So I have to find the ratio of this, right? Right click, delete, and then delete and right click, add traces, VN005 divided by VN002. The trace comes up, and then what you have to do is right click again, then add trace, not add traces, sorry. So add a cursor, let's say. So when you see there's 1 or something like that, when you move the cursor towards the middle. So when you move it along and reach 100 kilohertz, on the bottom right of the screen you're gonna see when you are reaching 100 kilohertz, right? So try to set it accordingly, okay? And when you're around, let's say 99.73, that's also okay. So I don't know if it lets me change it to 100. I don't think so. So I'm just gonna move it over to 100. I'm just trying to get as much closer as I can. So that becomes around minus 400 millidecibel, right? And then when I move it over to 100 kilohertz, it's going to be around 33.89. Okay, so these 2 points you have taken care of. And now the part 3 and part 4, I bet that you guys have already read the theories about it. Which components are contributing this rising amplitude versus the frequency characteristics, particularly at higher frequencies, right? And how you can show this. This is something you have to do by yourself. So I don't want to show this, but this reason I want to see all of you guys explaining this in your lab reports. All you gotta do is like just visit your theories or take a look at your book. I want to see if you have learned it or not. So I'm not going to give any hints regarding this. All you got to do is look through the books and your notes and figure it out, and let's see if you could figure it out correctly. It's not that much of a point, but the thing is I want to see if you guys learn. Okay, so that being said, that concludes the lab for today. So if you have any questions, let me know. Thank you.